So right now we'll be doing this particular question where you have an ideal bandpass filter to be designed with the specification given over here. From this concept, it should be clear that we are given modulus of omega. So since it is given as modulus of omega, it means that it can take up negative values as well as positive value. So what this basically means is that in the positive side, it will be lying between pi by 4 to 3 pi by 4, and in the negative side it will be lying between minus pi by 4 to minus 3 pi by 4. So that is a basic idea we should infer from a statement like this. If this is given to you instead of this particular form, this is something that you should get as a concept. So we need the filter to be specification to be drawn. So we'll be marking pi by 4. This will be 3 pi by 4 and this will be pi. Similarly, you'll be having minus pi by 4, minus 3 pi by 4 and minus pi. So you're having a graph like this and it is equal to 1 in this span. So this is how it will become, and here also it will become, and the value over here will be 1. This graph is HD of omega and this is omega, and the rest of the values will be 0. So this is the primary inference from this particular statement, and you're supposed to find h of z for n equal to 11. So moving on, if you remember, the first step that was to be done was you had to convert HD of omega to HD of n. So HD of n is equal to 1 by 2 pi integral minus pi to pi HD of omega e raised to j omega n d omega. So when we consider this span, you know that there is two valid intervals where this is equal to 1 and the rest of the intervals it is 0. So it will be like 1 by 2 pi whole into minus 3 pi by 4 to minus pi by 4 e raised to j omega n d omega plus pi by 4 to 3 pi by 4 e raised to j omega n d omega. It should be clear that hd of omega is equal to 1 in this span of intervals. So this is how the equation turns up into, and we can write it as 1 by 2 pi e raised to minus j n pi by 4 minus of e raised to minus j n 3 pi by 4 plus e raised to j n 3 pi by 4 minus e raised to j n pi by 4. This is how you get the equation in the form of the terms over here. Now we have to give an extra special care at this step and to get the general equation of hd of n. So when we are looking at these terms, we can see similar terms out over here. Here it is minus jn pi by 4, and here it is jn pi by 4 is available here. n 3 pi by 4 is here, and similarly we have the positive term. So generally what we have to note is that we need it in the form of e raised to j theta minus e raised to minus j theta to write it as minus 2j sine theta. So let us compare both these terms and understand which is available in this form readily. So if we look at this term, we can see that e raised to j n 3 pi by 4 minus e raised to minus j n 3 pi by 4 is available in this particular format directly. So we can write it as 1 by 2 pi e raised to j n 3 pi by 4 minus e raised to minus j n 3 pi by 4. That terms are ready. So we can ignore these two and let's compare the next. We have e raised to minus j n pi by 4 here minus e raised to j n pi by 4 here. Here comes a bit of a contradiction because we need it in e raised to j theta minus e raised to minus j theta format. But here it is in which form? E raised to minus j theta minus e raised to j theta. So this can't be equated to this one, but something can be done. The minus can be taken common and it can be written as e raised to j theta minus e raised to minus j theta. So eventually what would happen here is you take the minus common and we combine these two terms, e raised to j n pi by 4 minus e raised to minus j n pi by 4. We combine these two terms and let's see what happens now. So this becomes 2 pi. Oh, sorry, we had the jn term also common coming out here, so that will be available here. So this jn will be here into jn. Kindly don't forget that, even though I missed it over here, the jn term will be coming as a denominator. Integral e raised to j omega n d omega will be equal to e raised to j omega n by jn. So that jn term was missing out here, which I have added over here. 2 pi jn into, when we write it, it becomes 2j sine n 3 pi by 4 minus 2j sine n pi by 4. So we can combine, or we can cancel this 2j term, so it can be written as sine n 3 pi by 4 minus sine n pi by 4 whole divided by pi n. So this is the general equation of HD of n for this bandpass filter. Now we have got the general equation of HD of n. Our next job will be to find out the actual HD of n coefficient. So your n is given as 11. So your minus n minus 1 by 2 to plus n minus 1 by 2 would be referring to minus 5 to plus 5. So you need to find out the coefficients of h of minus 5 equal to h of 5. Then you need to find out h of minus 4 equal to h of 4. Then you need to find out h of minus 3 equal to h of 3. And h of minus 2 equal to h of 2. H of 1 equal to h of minus 1. And at the end you have to find out h of 0. So as you substitute the various values of n, you will be getting these coefficients. As per the text that is used as a reference material over here, the coefficients that you will be obtaining when you perform this calculation will be equal to 0. Please do that manually and see if it is correct. And the only thing that you need to take care of is you need to solve this equation while this equation is written in, or your calculator should be in the radians mode, and you should correctly write this equation where you are substituting the values. I mean, the required brackets have to be placed correctly, and then the value should be computed. Only then it would be error free. Otherwise there will be chances of errors. Anyways, for your convenience, I'll just solve out h of 0, or to make it clear. So we are applying L'Hospital's rule. When we apply L'Hospital's rule out here, you can see that our L'Hospital's rule is limit n tends to 0, sine n theta by n theta becomes equal to 1. So if our equation is considered HD of n where n tends to 0, will be like limit sine n 3 pi by n pi by 4 by n pi, where limit n tends to 0, minus of limit n tends to 0 sine n pi by 4 by n pi. So it will be like limit n tends to 0. We have an additional coefficient here, 3 by 4. So since 3 by 4 will be coming at the denominator, the numerator should also be having 3 by 4 at the numerator. So this becomes limit n tends to 0 sine n 3 pi by 4 by n pi 3 by 4, making it n 3 pi by 4 minus limit n tends to 0 sine n pi by 4 by n pi by 4. So here 1 by 4 should be coming at the beginning. So this term becomes equal to 1, and this also becomes equal to 1. So eventually it becomes 3 by 4 minus 1 by 4, that is 0.75 minus 0.25 equal to 0.5. So your HD of n is 0.5. Now, as you are supposed to find out h of z will be given by h of 0 plus equation will be summation n equal to 1 to n minus 1 by 2 h of n z raised to minus n plus z raised to n. So when we solve this particular thing, your h of 0 will be there, only h of 2 is available in that particular format. So summation n equal to, rest of the terms are 0, so only 2 is under concern here, so it becomes h of 2. Maybe we can ignore this summation, that is h of 2 into z raised to minus 2 plus z raised to 2. So this becomes 0.5 plus minus 0.3138 z raised to minus 2 plus z raised to 2. So try doing out this question, that is design an ideal bandpass filter with specifications as follows. HD of omega is 1/4, pi by 3 less than or equal to omega less than or equal to 2 pi by 3, and you have 0 elsewhere. Find it for h of z where n is equal to 11. So this question has to be solved in exactly the manner that was explained above, and please find out the solution.